All right, in this lesson, we're going to talk about a third manner of creating volume. You've already looked at volumes by revolution using washers and discs. And there's another volume by revolution, this time using cylindrical shells. And you can kind of see from this picture, basically we're taking a slice or a cross-section of a curve that is the height of the curve, and we're wrapping it around some axis of revolution. So each shell is a different radius away from that axis of revolution. So if we had had a horizontal axis of revolution, by the way, the shells would be horizontal. And then, like say this is my axis of revolution, I might have a shell up here that rotates around like that. And each of the shells would be a different distance from the horizontal axis of revolution. So what we need to do is we need to figure out the surface area of each thinly sliced cylinder. So we're going to add up all the surface areas to get to volume. So we're going to base our work on the surface area of a hollow cylinder. So just a very thinly sliced sheet, effectively, that's wrapped around in a cylindrical fashion around an axis of revolution. So we call these shells, cylindrical shells, and each one is rotated with the thickness delta R, which is basically R2 minus R1, where R1 and R2 are the distances from the axis of revolution. And the goal is, of course, to make the distance between these infinitely thin, so we'd get effectively to dr instead of delta R. But the actual radius that we're going to use for each cylindrical shell is going to be the average of R1 and R2. So we're going to call R equal to the average of the inner radius and the outer radius of this cylinder. And then the volume will basically get the circumference times the height times the thickness. So circumference, so think about a cylinder. Here's my cylinder. I'm not a very good artist, so haha on it not looking like a rectangular cylinder, but we are going to take the radius here, or the circumference here, excuse me, times the height, and then we need to multiply by basically this little bitty thickness here of each shell that we are revolving around. And that thickness is delta R. So we're really talking about the volume of an entire cylinder, 2 pi r h, but then just multiplying by this tiny little thickness so we get a sliver of the cylinder. And as I mentioned before, delta R, as R1 and R2 become infinitely close together, delta R will go to dr, just like a delta x would go to dx or a delta y would go to dy. And if we are revolving around a vertical axis, then the h value is actually going to be f of x, and then the r value will be x. And if we're revolving around a horizontal axis, the height, or f of x value, the height is the f of y value, and the r value will be y.